Here we have the function, exponential function 5 to the negative 7x, and we want to find the derivative. And so once again, if we just have a to the x, then the derivative will be ln a times a to the x. But here we don't have, the exponent is not x, it's negative 7x. And so we have to use the chain rule. And so here the derivative, if this were 5 to the x, then we would get ln a times 5 to the x, ln 5 times l to the x. But here, base 7, exponent negative 7, and so here we get ln 5, and then times the same thing. And the chain rule, we have to multiply by the derivative of the negative 7x. So what we did here was just we let u be negative 7x. And so this is equal to ln 5, and then times 5 to the negative 7x. And the derivative of negative 7x is just negative 7. And so the answer we will write as negative 7 times ln 5, and then times 5 to the negative 7x. Here we have the function 3x times 6 to the x, and we want to find the derivative. And so this is a product, and so we have to use the product rule. And so the derivative, the product rule is, it will be the first factor times the derivative of the second factor, which is 6 to the x, and then plus the second factor, and then times the derivative of the first factor. This is an exponential function with base 6, and so it's just like this. So it would be ln 6 times 6 to the x. So this would be ln 6 times 6 to the x. And then the derivative 3x is just 3. And this is the answer. Here we have the function 6 to the square root of x to the third plus 5, and we want to find the derivative. And so in this case, what we can do is let u be the square root of x to the third plus 5. And so u prime, or the derivative of u with respect to x, and recall that this is the same as x to the third plus 5 to the 1/2. And so the derivative, the chain rule, would be 1/2, and then x to the third plus 5, and then subtract 1 from the exponent, and we get negative 1/2. And then times the derivative of x to the third plus 5. And that's the chain rule. And so this is equal the derivative of x to the third is 3x squared, and then the derivative of 5 is just 0. And so altogether, the derivative of u 1/2 times 3x squared would be just 3x squared over 2. And so this is just the derivative of the exponent here. And so now we need the derivative of the function right here. So this is 6 to the u. And so the derivative of 6 to the u would be ln 6 times a to the u. So this is 6 to the u, since we let u be the square root of x to the third plus 5. And so the derivative of a to the u would be ln a times a to the u. So it would be ln 6 times 6 to the u. And then the chain rule is we have to multiply this by the derivative of u. And so this becomes ln 6, and then times 6, and then u is just the square root of x to the third plus 5. And then we have to multiply by the derivative of u, and the derivative of u is this. Here we have the function 5 to the negative 2x, and we want to find the tangent line at the point 0, 1. And so we need to find the slope of the tangent lines. And that's going to be the derivative evaluated at 0. And so first, let's get the derivative. So we have 5 to the x, then the derivative would be just ln 5 times 5 to the x, but here we have negative 2x, and so we have to use the chain rule. So this would be ln 5 times the same thing, 5 to the negative 2x, and then times the derivative of the negative 2x. So we get ln 5, and then times 5 to the negative 2x, and then times negative 2. And then we need the slope of the tangent line. And so in the place of x, we have 0. And so we get ln 5, and then this will be 5 to the 0, which is 1, and then times negative 2. So this will be negative 2 times ln 5. And that's the slope of the tangent line. And then the equation of tangent line and so we have the formula y minus y1 equal to slope, and then x minus x sub 1. So here we get y minus, this is x sub 1, y1, because this is the point that the tangent line passes through. So be y minus 1, and then slope is negative 2 ln 5, and then x minus 0. So the final answer will be this, and then plus 1.